So today we're looking at problem number 4 of the MIT integration be qualifying exam 15, which is the independent integral of secant of x or sec x. So let's see how this is actually a very beautiful problem. Let's see how we may be able to solve this. This is our problem. The integration of sec x, right, which is the same as integration of 1 over cosine x. Now cosine x is the same as cosine squared x over 2 minus sine squared x over 2, right? So this becomes an integral of 1 over cosine squared x over 2 minus sine squared x over 2, right? Now, with such a problem, substituting it so that t is equals to tangent of x over 2 is apt. So we have dt dx equals to a half secant squared x over 2. And so 2 dt over secant squared x over 2 equals to dx. And so 2 dt over secant squared x over 2 equals to dx means that we have 2 dt over 1 plus tan squared x over 2. And since tan x over 2 is t, we get 2 dt over 1 plus t squared equals to dx. So this is our first substitution, but we have a problem where we have 1 over cosine squared x over 2 minus sine squared x over 2 dx. And so if this is x over 2, the base angle, and so tangent being opposite over the adjacent, it means the hypotenuse is 1 plus t squared square root. And so cosine squared x over 2 is the same as 1 adjacent of hypotenuse 1 over t squared, and sine squared x over 2 is the same as t squared over 1 plus t squared, right? So the integral becomes 1 over 1 t squared minus t squared 1 plus t squared, and then the x is the same as 2 dt over 1 plus t squared, which is same as 1 plus t squared over 1 minus t squared, 2 dt over 1 plus t squared, and this and that would cancel. So we have 2 dt minus, right? And this is the same as 2 outside, 1 difference of two squares, where we have a squared minus b squared is equals to a minus b times a plus b. And thus, using this identity, we have converted this to this. So if our problem now has come to 1 over 1 minus t times t dt, this means that we have 1 over 1 minus t plus t divided by 2, because when you add 1 and 1 it becomes 2, so this would cancel. So we have our integral of 1 minus t, 1 over 1 minus t plus 1 over 1 plus t. Okay, so if we have the integral of 1 over 1 minus t plus 1 over t dt, this means that we have negative natural logarithm of 1 minus t plus natural logarithm of 1 plus t plus c, which comes to log of 1 plus t 1 minus t plus c. but t is equals to tangent x over 2. So integral now becomes log 1 plus tan x over 2 over 1 minus tan x over 2 plus c, which is equals to natural logarithm of 1 plus sine x over 2 plus cosine x over 2 over 1 minus sine x over 2 over cosine x over 2 plus c, which is the same as natural logarithm of cosine x over 2 plus sine x over 2 over cosine x over 2 over cosine x over 2 minus sine x over 2 over cosine x over 2, and this would cancel, plus c. This becomes logarithm of cosine x over 2 plus sine x over 2 over cosine x over 2 minus sine x over 2 plus c. And that means that, let me make this bracket, so we have cosine x over 2 plus sine x over 2, multiply the numerator by cosine x over 2 plus sine x over 2, and also the denominator cosine x over 2 minus sine x over 2, multiplied by cosine x over 2 plus cosine sine x over 2. So this and that would cancel to get 1, but there's a reason we're doing that. So the numerator becomes log cosine squared x over 2 plus sine squared x over 2 plus 2 cosine x over 2 sine x over 2 over difference of two squares, cosine squared x over 2 minus sine squared x over 2, plus obviously everything constant. Now this part here equals to 1, the popular identity, and this part here is the same as sine x. This part here, the denominator is the same as cosine x. So what that means is that we have natural logarithm of 1 plus sine x over cosine x plus c, which is log of secant x plus tangent x plus c. Let's focus on this a little bit. Actually, this could be the answer, but there is, so if we let y be equal to log sec x plus tan x, then it means e to the power y is equals to sec x plus tan x. Okay, and then negative y is equals to negative log sec x plus tan x. So negative y, e to the power negative y is the same as this negative goes up here, so we get 1 over sec x plus tan x. E to the power negative y is the same as 1 over 1 cosine x plus sine x over cosine x. E to the power negative y is the same as cosine x over 1 plus sine x, same as cosine x times 1 minus sine x over 1 plus sine x times 1 minus sine x, so that this could cancel with this. So we get e to the power negative y is equal to cosine x 1 minus sine x over 1 minus sine squared x. This is cosine x 1 minus sine x over cosine squared x, because this is the same as cosine squared x, which is the same as 1 minus sine x over cosine x, because this and that would cancel. So e to the power negative y is equals to 1 over cosine x minus sine x over cosine x is equals to sec x minus tan x. Therefore, e power y minus e power y is equals to sec x plus tan x plus sec x minus tan x, where this below same as this and this the same as this, so this and that would cancel, and so e to the power y plus e negative y is equals to twice sec x, and so e to the power y plus e to the power negative y over 2 is equals to sec x, and so 1 over e to the power y plus e to the power y over 2 is equals to cosine x, and this here is the same as 1 over e to the power y plus e to the power negative y over 2 is the same as 1 over cos y, which is equals to hyperbolic sec y, which is equals to cos x. Therefore, y is equals to the inverse of cosine x. And therefore, our integral of sec x is also the same as the arc hyperbolic secant of cosine x. So this is the same answer. So we could summarize this and say integral of sec x is the same as log sec x plus tangent x plus c, or the same as the arc hyperbolic secant of cosine x. These answers all hold. Thank you so much. Pretty much it was fun, but I hope you enjoyed following along. Thank you.